Yes, guys, how we doing? Welcome to another video. Hope you're doing very well. So this video is all going to be about the revolution that we are seeing now in the chip industry, in the computer industry. Thank you to Qualcomm and Snapdragon. What they've basically done is developed some chips, some ARM-based chips that are basically rival to what Apple have been releasing for the last 4 years. So basically, if you don't know, quick summary, what Apple did was they took the type of chips that are in all mobile devices, so your mobile phones, your tablets, and just any other kind of mobile device. Like they're in a lot of devices, even like a Bluetooth speaker, something like that. All chips like that are based on what we call ARM architecture. So ARM stands for Advanced RISC Machines. I think the RISC in there actually is another acronym, unbelievably, and that all comes from the company that developed them. So it's a British company. They were called Acorn Computers way back in the day. I think that goes back to like the 80s. But then there was basically like a spin-off of that realized a group of engineers within that company realized there was an opportunity to develop a chip with a different type of architecture. And long story short, that turned into like the ARM architecture. Now, the difference between ARM architecture and then kind of traditional chip architecture, x86, is basically the simplest way I can describe it is ARM takes one command at a time and then like kind of delegates it throughout the system to wherever it needs to go, and it kind of manages one task at a time. Doesn't let itself get bogged down with like hundreds of tasks at once. It just does one at a time, very efficient, very low power draw, which means chip doesn't get hot, so the performance stays high, and it draws less power, there's less demand on the chip, draws less power, so really efficient for battery life, as you can imagine, and just a more efficient system in general. But it kind of can't process as much data as like an x86 chip. Basically, that's the disadvantage. So it's why, you know, it still won't be used in gaming PCs anytime soon. Or if you're like a super professional like animator or 3D modeler or something like that that really uses hardcore, intense computational activities, that's part of your job. Again, you're probably still going to use very powerful x86 chips until I think one day ARM will take over and everything will be ARM, but which would be really cool. But I don't think that's going to be anytime soon. But at the rate we're going, you know, the amount, how much ARM chips are taking over, it's not, I don't think it'll be that long, you know, until everything is ARM, and you know, everything, the chip in your phone is the same architecture as the chip on your PC and your laptop, which would be really cool because it will mean ultimate compatibility. So all apps will be very compatible with all different devices. So the apps on your phone will be way more compatible with the apps on your laptop and on your desktop and anything else in your streaming hub. It will just make things a lot easier for developers and make things a lot more streamlined, and devices will be able to talk to each other way more easily, and it will make life a lot more easier for developers. So we'll see. And saying, you know, it's not used in games, Apple, their last, you know, it seems like every event now, Apple bring out, you know, they make an announcement about games. So Assassin's Creed Mirage, which is like really graphically intense game, Resident Evil 4, and the last announcement at WDC, there was a ton more games, AAA games, graphically intensive, that because the developer built the game for ARM architecture from the ground up, it works really well. So, you know, so it can work. It just means that, you know, but whether an actual, you know, 3D modeling tool or really high-end processor intensive video editing stuff can be done on ARM chips, I think the jury's out. I don't know if that could actually happen yet. I don't know if that's possible. I don't think it is. But like I say, I don't think we're far away from it happening. So that's basically the difference. So whereas an ARM chip uses single commands and just processes one command at a time, the x86 will take all the commands at once. It will just process. It's an absolute beast, right? So they get a lot hotter and they draw a lot more power. That's because they're just doing a lot more at any one time than an ARM chip is. They're just processing tons and tons of stuff at once, and it's all being done on the chip. Whereas ARM works a lot better with a separate GPU, separate MPU, just separate components to do specific things, and it offloads these tasks to those different things. It doesn't do everything itself, whereas an x86 does a lot more things itself, a lot more processing actually on the chip itself. So that's the difference. So now we're seeing, Microsoft released its range of Surface laptops, had a massive event to announce how good the Snapdragon chips was, and that they were partnering with Qualcomm, and that their Surface laptops were going to have these new chips in, and it was going to change the world, and they were going to catch up with Apple. They bashed Apple quite a lot. They were saying about how much better their Surface laptops are than the Macs. I don't think there's been much independent testing on that, so we'll see. I think the jury is still out on that a bit. There are Cinebench and Geekbench tests, but I think until tech reviewers have actually got both laptops in front of them, you're not really going to know. And they're doing, very specific testing and actual real use cases. So we'll see. But HP, I'm just referring to some notes that I wrote, but HP, Microsoft, Acer, Lenovo, Dell, and Samsung are all releasing, I think they even released them early as last week, released all their new range of laptops. You can see them on the Windows website, all the different laptops. That's how much Microsoft are behind this. Microsoft are behind this so much that they're putting competitor laptops on their website to show that this is the way forward, all to try and anyone who was thinking of moving, to Apple so that Apple could get more market share, away from Windows. They didn't want that, because as much as Microsoft want to push, Surface laptops, the big win for them is that everyone still uses Windows, or more people still use Windows. So whatever manufacturer that ends up being, as long as it's not, because Microsoft will still get the licenses for Windows. So what Microsoft really want to make sure, even if it's not that everyone is using a Surface laptop, is that you're at least not using Macs, because that they get no revenue there, obviously, because that is Macs hardware and software. Whereas all the other manufacturers can bang out laptops, but Microsoft are going to take their cut because they need the software from Microsoft. So apparently the CPUs. So what the Snapdragon Elite and Snapdragon X Elite chips are also, they're a system on a chip, and this is another thing where they've kind of copied from Apple. I mean, I think maybe it was happening before Apple did it, and it's basically what they call a system on a chip. Now what that means is, rather than just have a CPU, and that is kind of like the main chip, what NVIDIA did years ago was develop separate a GPU. So that's something that just only does graphics, so visual things and really computationally intense processing, and mainly graphics and animation and rendering is done on the GPU. So everything that the CPU used to do that, or there'd be a section of the CPU that would do that, it would have cores allocated to it. But then that changed to everything being offloaded to this GPU, which obviously massively improved games and graphics and your ability to render things. That's why graphics are as good as they are today, because of that. And then you had MPUs, which is all of the AI functionality and AI processing. All AI tasks started to be done on MPUs. And I think we're going to see more of this, as in the CPU will do less and there'll be less functions. But what Apple did was they took all these separate things, the MPU, GPU and the CPU, and then they combined them back onto one kind of bigger chip. I say bigger, this is 3 nanometer technology, so these things are a speck on your finger. They're absolutely tiny. So, but they took all of that stuff and they put it onto one chip, but they were still separate things. They were still things that were built to do one very specific thing, rather than multitask and do everything. And the CPU at the center of it just kind of delegated the different tasks and then received the data back, if you know what I mean. So that made it way more efficient, and Snapdragon have done the same thing. So these are all systems on a chip. So there's the GPU, CPU, NPU all on one chip, and it's all ARM architecture. So it's super efficient, and that is why they're being able to take on Apple. Now the CPU element they've called Orion. The CPU itself is twice as fast as the chip before that was x86, twice as fast, on a quarter of the power. So I don't know if that's a genuine comparison. They're probably being a bit naughty there by factoring in the amount of power that's being used. So they're probably saying it's this amount, it's this powerful, but it's way more powerful, 50% powerful, because they're talking about power per watt. So they're probably being a bit naughty. I doubt it's doubly as powerful as an equivalent power x86 chip that gets way hotter. I don't know. I doubt it. They're probably just being a bit kind of sly old dogs there with how they're presenting that information. But apparently twice as fast with 1/3 power, which is incredible. 4.5 times the AI power. I imagine that comes from having the NPU, the neural processing unit on there. So they can absolutely smash out AI tasks. And what I imagine Snapdragon have done to try and get a bit ahead of Apple is really massively focus on AI, because AI is just so massive at the moment. So whoever has the biggest, most powerful NPU is going to be a winner, and people are going to use those chips because AI is like so important to everyone now. You've got to have like flashy AI stuff on your computer, haven't you? Or at least your computer's got to be able to handle that kind of stuff. 4nm system, which is obviously the smallest system. The smallest type of production is 3nm. So this is 4nm. So they've not messed around. They've really gone for like cutting edge technology using 4nm with 12 high performance cores, which is incredible, at 3.8 gigahertz, and then a dual core BERT. So when they're using more than one core, dual core, it's 4.8 gigahertz. That is massive. That's like really incredible performance, especially for a system that is still going to have incredible, to have that amount of power in a system where you're going to get 20 hours of battery life is amazing. Like that is well up there with what Apple have been releasing over the last few years, and probably exceeds it in some areas. From what I've seen, multi-core, the Snapdragons are better than Apple, but single core, Apple is better. So we'll see how that pans out, whether Apple try and improve in those areas, and then, you know, whether Snapdragon even ends up taking a lead, or will Intel come out, you know, with something amazing, which would be brilliant. You know, we want as much competition as possible, right? So apparently, like I said, they took a few swings at Apple here. They weren't messing around. Tim Cook must have not been happy, but apparently it's 10 times faster than the latest M3. Very impressive if that's true. Incredible. System on a chip, like I've said, so CPU, GPU, all on one die. And this can do things like it's capable of supporting 2 5K monitors at once. From what I've seen, because Windows, you know, tend to do it historically as well, and I guess these chips have been designed to do it, but I don't know if ARM architecture tends to struggle with that kind of thing. But yeah, two monitors at 5K at once is amazing. So I assume if it's less than 5K, the lower spec monitors, hopefully it could run like, I don't know, 3 or 4. It's been a huge frustration with a lot of people with the new Mac laptops, is you can only like use one monitor on the MacBook Airs, and then, you know, 2 monitors on the Pros. Like really frustrating. You know, you should be able to use multiple monitors, like, you know, up to 3 or 4 if you want. You know, it's a shame that that is a sacrifice here, but again, I'm sure the technology will improve and we'll be able to do that at some point. But yeah, that's it, guys. So like, nice quick video, or at least quick by my standards. But yeah, that's what the revolution's all about. That's what Snapdragon, the Qualcomm processors, are all about. Different type of architecture. That's the specs, you know, we're kind of hearing. So they're super high performance for low wattage. Like I say, that kind of performance, you know, 4.5 times power. CPUs are like twice as fast, all for massively increased battery life at like 20 odd hours, which I'm sure you'd agree is like pretty amazing. So really leveling the playing field with Apple there. And, you know, let's see how it evolves and where it goes. But exciting times, you know. The competition's really good. It's heating up. It's going to force Apple to innovate even more, because they don't have an edge in that area now. And, you know, it's good that there's this like level playing field and good competition, and everyone's pushing each other. We love to see it. It's how it should be. So hope that was interesting, guys. Hope you got something from that. Please smash a subscribe, smash a like, drop some comments in. Let me know what other videos you want to see, or if you think I missed any important details. And thanks, and I'll see you in the next one. Thanks for watching.